Let's look at the formulas for surface area of prisms and cylinders. Hopefully you remember that prisms and cylinders have two congruent parallel bases. A lateral face is not a base, but a base is a face, so that word lateral is what makes the difference. The edges of the base are called base edges, and the lateral edges are the edges of the lateral faces, such as these red lines here. The lateral faces of a right prism are all rectangles, as we have discussed in class. An oblique prism has at least one non-rectangular face. So notice you have a bunch of parallelograms over here. The altitude is still the height of the solid. It is perpendicular to the segment and it connects the two bases. So the height of a three-dimensional figure is the length of the altitude. Notice we have an oblique prism here. The altitude is outside of the prism. So make sure you check, is it a right prism or is it an oblique prism? The surface area is like if you're taking a present and you have to wrap it. What is the total area of all the faces and the curved surfaces, if it's a cylinder, of a three-dimensional figure? The lateral area is just the sum of the lateral faces. So here are the formulas you need to know. These are on your formula chart, but what you need to remember is that that big P will be the perimeter of the base. So you have to know which face is the base. And that capital B is the area of the base. Now be careful, because these formulas only hold true for right prisms. To find the surface area of an oblique prism, you have to have the net and you have to find the areas of the faces and add them together. So let's look at right prisms to practice our formulas. Here we have a rectangular prism, and they want us to find the lateral area and the total surface area. So let's look at the lateral. Looking at your formula chart, here's our formula. Let's make our list. The perimeter and the height. Remember, this is perimeter of the base, so I'm going to shade in the base so we can keep that separate. So the perimeter, we just add up all the sides and we get that it is 32 feet. The height is what's connecting the two bases, which is 14 feet. From here, we just substitute in and we get that it has a lateral surface area of 448 feet squared. Now for the total surface area, well, notice we already found this. So we're just going to put that together because we already know that's 448 feet. And then we need to find this area of the base. Well, area of the base here is base times height. Excuse me, I was doing 9 times 7 and got 63. Let's try that again. How about 9 times 7, which is 63? So when we substitute in, we have 448 plus 2 times 63. I want to warn you, don't forget about this 2. It is very easy to leave it off, so double check to make sure you have the 2 in your formula. That's why it's so important to copy the formula down exactly as it shows on your formula chart. And when we add these together, you get 574 feet squared. So the lateral surface area is 448 and the total is 574 square feet. Make sure if you're finding both, go back and check your answers and do they seem reasonable? Is the lateral smaller than the total? That should happen because this is only for these lateral faces going around. If it's not, go back and check your math. I want you to do this one for class to find the lateral and total surface area of a right regular triangular prism. Has a height of 20 centimeters and base edges of 10 centimeters. My hint to you here is to draw and label the base only. You know the height is 20 centimeters. That's easy to substitute in. But make sure you draw the base and label in order to find the perimeter and the area. Have this ready for class on Monday and Tuesday. Let's look at cylinders. The lateral surface of a cylinder is that curved surface going around the cylinder. It's connecting the two bases. The axis in a right cylinder is also the height or the altitude of the cylinder. The axis of the oblique is not perpendicular to the bases. So let's look again, the formulas apply to the right cylinder, so let's look at right cylinders. Here are the formulas in order to find the lateral surface area and the total surface area. So here they want us to find the lateral and total. Here they want us to give our answer in terms of pi, which means that symbol pi should remain in our answer. So let's look at the lateral. Here is my formula for lateral surface area of a cylinder. We have a radius, we have a height. Our radius here is 8 inches, our height is 10 inches. So when we substitute in, and multiply our numbers here, we get that it's 160 pi square inches. That is the exact total or lateral area that you need. So now let's look at the total surface area. I'm writing a different formula because I want you to see that this total surface area is the same thing as 2 pi rh, which was the lateral we found, plus the area of the two bases. Sometimes to me that formula can look a little complicated, so all we did was we factored out a 2 pi r out of each term. We're left with an h, we're left with an r. It does not matter which formula you use, just make sure you use it correctly. The only variables we have are r and h, which we already have up here. So 2 pi times the radius times the height plus the radius. So we can do 2 times 8, and then we combine our like terms here. And 16 times 18 is 288 pi square inches. So here is our total surface area for this cylinder. This one is what you're going to do for class. You're going to find the lateral and total surface area of a right cylinder with a circumference of 24 pi centimeters and the height that is equal to half the radius. So remember, it's giving you the circumference. So use the circumference of the base in order to find the radius. Remember, the radius is radius is twice as big as the height, or the height is half the length of the radius. So you have to use your circumference first. Make sure that you leave your answer in terms of pi. So let's look at composite figures. Just like with perimeter and area, we could find the total perimeter and total area of two or more figures put together. We can do the same thing for surface area. So we need to look at what we have, and here we have a triangular prism plus a rectangular prism. But remember, this is surface area, so we're only calculating the amount of space amount of area that we see. So if these are connected, we don't really see this rectangle on either solid. So when we find the triangular prism surface area, we have to subtract out that one rectangle. Same thing for this rectangular prism. So what we're going to do is we're going to get started, and then you're going to complete it in order to show in class. I'm going to look at the triangular prism. So we look at the total surface area, which is perimeter of the base times the height, plus 2 times area of the base. So if we look at this prism here, the perimeter should be this rectangle. So let me make that another color. The base here is this right triangle. So we need, in order to find the perimeter, we need to know all three sides. Well, we have, you can pull it down here if it helps you. We have 3 centimeters, 4 centimeters, because if this was 4, we know this is 4. We need to find the hypotenuse. Well, by using Pythagorean theorem or remembering your triples, we know that the hypotenuse is 5 centimeters long. So our perimeter is 3 plus 4 plus 5, which is 12 centimeters. The height of the prism is 2 centimeters, because remember we have to connect the two bases. So be careful that looking at your solids, are they laying on a lateral face or are they laying on the base? So you got to pay attention to those details. We'll also need the area of the base, which remember is a triangle, so base times height divided by 2. Our base is 4, the height is 3. So I'm going to come down here and show my side work. Now we have all the information we need to find the total surface area of the triangular prism. So we have 12 times 2 plus 2 times 6, which gives us 24 plus 12, which gives us 36 square centimeters. But remember, this is the total. So we have to subtract out this black rectangle that we have shaded in because we do not see that part. So the area of that rectangle, let me just kind of draw in, this is the rectangle we're taking out, is going to be base times height, which in this case is 4 by 2, which is 8 square centimeters. So we have to subtract these two, and we get that the triangular prism has a surface area of 28 square centimeters. Now remember, this is just the surface area that we see. So now what I want you to do is you get to do this rectangular prism and then think about what you do in order to find the surface area of the composite figure. So the rest of this problem is due in class. Now remember when we talked about change in dimension, we had scale factors, and remember that scale factors you always multiply. So here, if the edge length of the cube is tripled, this is our scale factor. All it wants to know is to describe the effect on the surface area. Well, since we're dealing with area, we have to have 2 scale factors. So all we have to do here is scale factor times scale factor, which is 9. So really, if we were to triple the length of this cube, the surface area would be 9 times bigger. And that's all we have to do. This one you're going to do for class. Same idea. The height and diameter of the cylinder multiplied by 1/2. They want us to describe the effect on the surface area. So all I want to know is how does the surface area change by using your scale factors. I don't want to know the new surface area, I just want to know the effect. Have this ready for class on Monday and Tuesday.